Well, hot diggity dang, we are on to converting from rectangular coordinates to polar coordinates. Now, just as a reminder, we know this since, ninth grade, that rectangular coordinates are given as x comma y, where you've got an x-axis and a y-axis. But we want to change it so that we can graph it as r comma theta, remember, on that really cool looking polar coordinate like that. So this is the opposite direction. And here, clearly, we want to solve for r and we want to solve for theta because we want to go from xy to r and theta. So using this picture, let's solve for r. And to do that, we would just do Pythagorean theorem. X squared plus y squared equals r squared. Then square root both sides, and you get r is equal to the square root of x squared plus y squared. So that's all we're going to have to do for finding the radius, is just do Pythagorean theorem with the x and y coordinate. The theta is a little bit harder, but not much. Theta is going to be inverse tan inverse of opposite over adjacent. And the reason why I chose the opposite and the adjacent is because, remember, we were given x and y, so that's why I chose those two coordinates. So my opposite in this case is y, and my adjacent is my x. All right, so here's the summary right here, and this is what you'll be given on your test. R is equal to the square root of x squared plus y squared, and tan inverse of y over x will give you theta. Are you ready to rumble? I think I am. Okay, convert the following from rectangular coordinates to polar coordinates. Let's find radius first. That's going to be equal to 2 squared plus 2 root 3 squared. And I want to talk a little bit about what this 2 root 3 squared is. 2 root 3 squared, remember the squared squares both of these things. So 2 squared is 4, and square root of 3 times the square root of 3 is the square root of 9, which is 3. Or just think about if you have a square root and you're squaring it, they're inverses, so they cancel out. So that root 3 squared becomes a 3, and this whole thing becomes 12. Or you could put in your calculator and you'd get 12. So really this gives us r equals the square root of 4 plus 12, which is the square root of 16, and r is equal to 4. Good stuff, Maynard. All right, now we have to find our theta, and we're going to use this formula to do that. But it's really important that we stop, just like we did on our vectors unit, and we talk about where it's located. Well, when we graph 2 comma 2 root 3, this is going to be some positive decimal. So you could find it if you wanted, but it's not really important. We know that 2 is going to be in the right direction and 2 root 3 is going to be in the up direction. So our theta, or our angle for this coordinate, is going to be in the first quadrant, which is super nice. So we're going to do tan inverse. Theta equals tan inverse. Remember, it's y over x, so it's going to be 2 root 3 over 2. And when I get that theta is equal to, you could also see that this cancels, make it cool. I don't suggest you doing this in your calculator because we can actually get a more accurate answer here, because remember, this asks you for radians. Well, the tan inverse of root 3, where is that going to be? That's a little tricky. We're basically saying we want the angle where tan is root 3. That's what this whole thing says right here. I want the angle where tangent is root 3. Well, instead of saying tangent, I'm going to say sine over cosine, because those are the same thing, right? We know that from our last unit. So where does that actually happen? Well, here it actually happens right there. Again, we know we're in our first quadrant, so we were kind of narrowing it down to all of these. So we didn't really have many to choose from. And so here's why. If I do my sine divided by my cosine, so that's going to be root 3 over 2. If I'm dividing by 1/2, that's the same thing as multiplying by the reciprocal. In this case, the reciprocal is 2 over 1. So this right here, what I've just done is sine divided by cosine. The 2's cancel, and I'm left with root 3. So I know that that answer is pi over 3. So theta here is going to be equal to pi over 3. All right, so our final answer is going to be a radius of 4 that came from here, comma, pi over 3. Now, we're certainly going to practice problems like this, but the ones on your test are a little bit easier to find that pi over 3 or that angle. Okay, let's try another one. So we've got Pythagorean theorem to do first. So we're going to do r equals negative 2 squared plus negative 2 root 3 squared. Well, that's going to give me square root of 4 plus, well, negative 2 squared is 4 and root 3 squared is 3, so this gives me 12. Really, that's the same problem as the last one that I pulled off to the side. And I get square root of 16, r equals 4. Now, we're done with the radius, but look at our coordinate. Where is it located? If you were to graph that rectangular coordinate, you'd find that it was left 2 and then down to root 3. So you're actually located somewhere over here. So let's go ahead with that in mind and find out what angle we have. Well, it's going to be theta equals tan inverse of y over x. So here's my y, here's my x. So a negative 2 root 3 over negative 2. Negative 2's cancel. So I'm looking for an angle that when I do sine over cosine, I get root 3. And I know it has to be here in this quadrant. Well, that answer is going to be kind of the similar one. Remember, the other one was this one because our coordinate was in the first quadrant. So obviously our answer is going to be this one, because if I do this right here, if I do my sine over cosine, let's do that. Remember, sine is the second one. That's negative root 3. So that's my sine divided by this. So that's my cosine. Well, dividing by negative 1/2 is the same thing as multiplying by its reciprocal. Well, the 2's cancel. The negative times the negative becomes positive, and I do get root 3. So even though this is the same exact numbers as the last problem, because we were located in the third quadrant, by looking at this negative and the negative, we actually chose a different angle. In this case, we chose 4 pi over 3 because when we divide sine over cosine, we get the root 3 that we wanted right here. So our final answer, we know, is that our theta is equal to 4 pi over 3. So our coordinate's going to be r theta, or 4 pi over 3. What a joy. What a joy. All right, now these next problems are a little bit more similar to what you would see on your test. In other words, I think they're a bit easier in terms of finding the inverse angle. But I still want you to practice with examples 1 and 2 because it's good to make your brain big. All right, let's go ahead and find our radius. This is going to be the square root of x squared plus y squared, or negative 4 squared plus 0 squared. Well, I'll be a monkey's uncle. This is going to be square root of 16 plus 0, which is the square root of 16, is 4. Looks like I'm obsessed with the radius of 4. Now, theta is going to be tan inverse of y over x, or in this case, that's going to be 0 over negative 4. Well, that means theta equals tan inverse of 0. Well, where is sine over cosine 0? Well, that would mean that sine, or the second coordinate, has to be 0, right? Because we know it's cosine comma sine. So it would have to be some sort of 0 for sine, so it would be 0 divided by some number. It doesn't even matter what that what that first coordinate is right there. Okay, so where is sine 0? Sine is 0 right here and right here. And you're probably saying, well, which one are we going to pick? Well, whenever you're confused about which one you pick, you just look at the original coordinate and it's -4, 0. So -4, 0, if we were to graph that, would have been over here, right? Just think of graphing a rectangular coordinate. So we're certainly going to choose pi. Now, just to emphasize this, we have to show that when I do sine over cosine, I get 0. So this is my sine, this is my cosine. So is 0 divided by 1 equal to the 0? Yes. And why am I doing sine over cosine? Well, that's the same thing as tangent. All right, so we've just decided that our theta is going to be equal to just plain old pi. So our coordinate is 4, pi. And let's just quickly graph that. That would be 1, 2, 3, 4, and it would be right. Well, pi is here, right? And then 4 away would be here. So that would be that. And does that make sense? If I were to graph -4, 0, that's -4 zeros right there. So that's kind of a quick check step. You can only do it when it's on one of the axes. Otherwise, you can't do that check. Okay, let's do another one that, hint, hint, nudge, nudge, I think would be acceptable to have on your exam or a final, something like that. Here, let's go ahead and find the radius. This is going to be 3 squared plus -3 squared. This is going to be r equals 9 plus 9. R equals the square root of 18. R is equal to, let's break this into two different radicals. I'm going to say root 9 times root 2, because 9 times 2 is 18. But of course, we can reduce square root of 9 to 3, and then we'll have root 2. Well, I said 2 and I wrote 3. I'll be. So there's our radius. And now we need to find our theta. So theta equals tan inverse of y over x. So that's going to be my y is -3 over 3. So tan inverse of -1 theta. Okay, so now we need to look at the coordinate grid. And where the heck would we get an answer like 1 or -1? Where we're going to get it when the coordinates are the same, when our sine over cosine are the same. That makes a lot of sense. And just go ahead and let's look at where this coordinate is. Where is 3, -3? 3 would be over here, -3 would be here. So we're obviously in this section right here. And I want to just kind of convince you even more that this is the right angle by doing sine over cosine. So if I did the sine, which is the second coordinate, over the cosine, that's -√2 over 2 divided by √2 over 2. I got that cosine right there. So this is sine over cosine. And if you do that math, since it's the same number divided by the same number, you get 1, and there's that negative right here, so you get -1. So in other words, we have found the angle for where tangent is -1, and that's going to be at that 7 pi over 4. So our answer here is going to be theta equals 7 pi over 4. And you can kind of memorize that. If you have a 1 or a -1, it's going to be either at the pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4, because that's where you'd get a 1 or a -1. And then just check your coordinate to see which one it is. So our answer here is going to be 3√2, 7 pi over 4. All right. Okay. Now we're getting to a point where when we do this problem, we're going to actually pick up our calculator. And the way that we know we're going to be able to do that is when we do the division like we did here. Notice how we got a value that I could get through the unit circle. Like we can get a -1 by dividing sine over cosine. Same thing here, we can get a 0. We can get a √3 by dividing sine over cosine. This next one, that is not the case. And I'm going to tell you a little bit better on the test saying you can use a calculator to do this problem. But typically, if I have a degrees problem, it's a situation like that. All right, let's run with this. We've got a radius of 4 squared plus -8 squared. So that's going to be 16 plus 64. That's going to be the square root of 80. And I can write that as square root of 16 times the square root of 5, because 16 times 5 is root 80, and that gives me 4 root 5. I love the radius, it's easy. So now we have to find theta, and it's in degrees, so you want to change your calculator into degrees. And we want theta equals tan inverse of y over x. So that's going to be negative 8 over 4. That's theta equals tan inverse of negative 2. And I'll tell you right now, you could go through this unit circle and do, you could do sine over cosine, won't be negative 2. This over this won't be negative 2, etc. It's never going to work. But so what you can do here is actually pick up your calculator, make sure you're in degrees, and actually plug this in. So you would do second on your calculator, then press the tangent button, which will give you that tan inverse, and then you're going to put in that negative 2 and close your parentheses. So finding the tan inverse, please practice this. Make sure that you get an angle that is 63.44. Now, please don't stop there. Be careful. You just found possibly the reference angle. You've got to be awfully careful. And you might say, Miss Sorensen, I actually got a negative. And you'd be right in this situation. But I'm going to show you why I would prefer a positive. And I'll show you that in a second. So where are we at? Let's look at our coordinate. We always have to stop and say, where am I? Well, I'm at 4, negative 8. So 4 and then negative 8. Okay. So you just got that this angle right here is 63.44 degrees. And that makes sense why it's a negative, right? Because it goes below the x-axis. But I don't love saying negative. And the reason why is because I just like, if I did instead tan inverse of just positive 2, I would get 63.44. And then that would tell me that all I have to do to get the angle that I really care about, which is this one right here, I just have to do 360 minus 63.44. So I don't care if you do the negative or if you do the positive, just really find out where your angle is located. And I like doing positive because it always tells me what the reference angle is. So here I know that 360 minus 63.44 actually gives me 296.57. So that's that green angle that I have right here. And that makes sense, right? So our final answer here is going to be 4 root 5, comma, 296.57 degrees. All right, stay with me for one more. All right, I know we can do this. So we're going to do r is equal to negative 2 squared plus negative 3 squared. That's going to give me 4 plus 9. R equals the square root of 13. And that's it. I don't need to go any further with that. So now I'm going to have tan inverse of y over x, which is negative 3 over negative 2. And that's going to give me tan inverse. And like I said, I always just like to make this positive, but you don't need to. You can kind of deal with it if you don't. But we know that we won't be able to get 3 over 2 over here. So this is where we pick up our calculator and we do second tan inverse. Well, we do second tan, and that gives you the tan inverse of 3 over 2. And I get 56.3 degrees. But where is our coordinate located? I keep saying this. We have to think about where is negative 2, negative 3. Well, negative 2, negative 3 is going to be over here, right? Because we've got negative 2 is left 2, and then we've got down 3. So this 56.3 degrees is actually right here. Okay? So that means you're really 180 degrees, which is this right here, plus that 56.3 right there. So it's going to be plus 56.3. And that gives me 236.31 degrees. All right, so just know that you're finding your reference angle. I like to keep it positive, so you're finding your reference angle. And so our final answer here is going to be root 13, 236.3 degrees. Thanks for watching, everyone.